What's up, geeks, and welcome to the channel. In the previous videos of this series, we introduced TDD, implemented several unit tests, and discussed their naming conventions. Today, we pick up right where we left off. So, let's bring back our bank account class alongside the unit tests we created for it. The current implementation of the withdraw and deposit methods in the bank account class don't return values, so the tests we created after calling one of those methods will assert the assumed side effect on the object passed to them. Notice how the tests we created take the same general approach. We create an object, we do something to that object, and then we test the result. We previously saw the phase red-green refactor that describes the overall process of TDD. Here, each individual task can be summarized using the AAA rule: arrange, act, and assert. So, to arrange is to set up the data we need to manipulate. In this case, we created a bank account object. To act is to change it, to do something to it. And to assert is to check the result of that change. Also keep in mind that not all arrange, act, and assert can be done with one line. Some will require more. And that's another reminder that each test is intended to be self-contained and that you should be thinking about what each of these steps apart contribute to a successful unit test. Alright, say we added a return value to the withdraw method. Then we can go ahead and assert that value directly without a need to access the object. In this case, the AAA rule was done in 2 lines. We created an instance of the bank account and then called assert equals on the return value. So, if your methods return a value, you test that. If your methods affect the state of an object, you test that too. And depending on the behavior you need, you might require tests for both the return value and the side effect of a method. Additionally, it's also common to create tests that deal with incorrect input or some other issue that throws a known exception, which can be caught and handled elsewhere in the application. To test this, let's say I want to throw a number format exception in case the user passed a negative amount to the deposit method. So, let's write the test first, and to do that we need to make use of the assert throws method. This method tells JUnit that if any code in the lambda expression method throws this specific exception and no other kind of exception, we will go green. If it throws any other kind of exception, we will still fail. You can also go ahead and add extra checks on the actual message or exception returned by this call. Now we can write the logic that actually throws that exception, run the test, and make sure we are green. So as you see, we can not only assert modified objects, but also return values and exceptions thrown. Usually we assert a positive outcome or some kind of success, but also sometimes we can assert a negative outcome. Like if we pass in this bad data to this particular method, we expect this error or exception to happen. Okay, since the beginning of this series, we've already explored a couple of concepts. First, that for each class in our application, we should typically create a separate unit test class. And in each test class, we'd have multiple self-contained test methods where each handles a specific path in our application. We've also seen that these individual test methods usually consist of the AAA approach. We arrange, act, and then assert. We set up some objects, do something to them, then check the results. Now, what is very common is that multiple test methods in the same unit test class end up sharing a lot of similarities in their arrange part. Often, they're going to repeat the same code that initializes the object representing the class we are trying to test. In the example you see, we are creating the same bank account object at the beginning of each test method, and we know that duplication is bad. So you'll be glad to know there is a way to simplify this. JUnit 5 includes the idea of special methods. Even though these methods are usually named setup and teardown, their names don't actually matter. We have these annotations at before each and at after each, just like the at test we already seen. These tell JUnit that the setup method is to be called before each test and the teardown method is to be called after each test. You do not need both, you can use one or the other or both or neither. In our example here, we are going to instantiate a bank account object in an at before each method, and now we can go ahead and remove that code from all the individual testing methods. Now, here's the really important idea about the at before each and at after each that a lot of people miss the first time around, especially if they're still on JUnit 4. Back in JUnit 4, these methods used to be named @before and @after simply, and a lot of people saw these methods as having this kind of effect, that if you have setup and teardown, setup will be called at the start, then your testing methods, and then teardown will be called at the end. But really it's this, it's before and after every single test method. If you have these methods, JUnit will call the setup method before each test and teardown after each test. Hence why in JUnit 5 their name was changed by appending the word each to them. Now, if what you actually want is a method that runs once at the very start of all the test methods or once at the very end of all the test methods, no matter how many test methods you have, you can create another couple of methods and use the @beforeAll and @afterAll annotations in JUnit 5. The names of the methods do not matter, but the typical names we use are setup class and teardown class. And if you are on JUnit 4, these methods will be the @before class and @after class. Okay, in the last section of this video, I want to go through a few common questions and misconceptions about unit testing and TDD. We'll begin with the question, do we need to test things like the getters and setters of our classes? Well, it depends if you have simple getters and setters similar to the ones generated by your IDEs or not. If these simple methods are what you're talking about, then no, these don't need testing. There is no point at all in creating specific unit tests for this kind of stuff, because there's simply nothing you could do if it failed. You're trying to test everything that could break so that you can later fix it. You're not trying to test the language itself. You're testing your own logic. So it's fine to assume that some things will just work, that a return statement will work, that if you add 2 and 2, you will get 4. That's not the kind of stuff that needs testing. However, if you create a custom setter that contains a specific logic which might affect another object, well then yes, feel free to create a test to make sure your logic works. Next, do we need to test private methods? Well, usually in most languages you can't do this anyway, and personally I'm not a fan of testing private methods, especially if the change they apply is very small and very specific. Instead, what you can do is test a public method and make sure there is a test or multiple tests that verify the impact of any private method it calls. The next question is a big one. What are the benefits of TDD? Why am I already at video number 4 about it? What does TDD give us that can't be achieved by the normal way of unit testing? Well, unit testing allows for early bug detection. It helps us understand how the code works, resulting in better design decisions. TDD allows writing smaller code having single responsibility, making the code simpler to understand. TDD will make sure that your tests are done, hence giving you more confidence while refactoring the code. Having a set of automated tests will help you fix any regression you make while refactoring. You know, I can go on and on about this, but I want to tackle more topics, so I'll just end with this. TDD forces design for testability, which means that the code you write will be testable up front, and you know it because the test was already written. One of the worst things about writing tests is having to go back and change working code because it isn't testable. Now, a lot of misconceptions were already tackled in this series, one of them being that you need to write all the tests before you write the code, and we saw that the process of going back and forth between the testing code and the application code should be very fast. Another misconception is that you must always refactor your code after you green your test as per the green-red refactor sentence. Well, yes, refactoring is good, but most of the times, unless your code is unreadable or you've benchmarked it and discovered it's too slow, you probably don't need to refactor. Finally, I want to end this video with a tip that will hopefully change the way you test. In some cases, mocking is a code smell. I know we haven't tackled mocking yet, and we'll do that in the upcoming video of this series, but if you have to do a lot of mocking to create a proper unit test, then maybe that code doesn't need to be tested in the first place. And with that said, if you also find yourself not able to test anything because all of your code is interdependent, so you're tempted to do all of your testing with end-to-end tests, then I'm sorry to say you should probably rethink your testing strategy. Because you're going to end up with inadequate test coverage, which will also be the topic of a future video, by the way, and a tightly coupled code which will become harder to maintain over time. So that's it for this video. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.